12 equal wires, each of resistance small r, are joined to form a skeleton cube. Find the total resistance between the two opposite corners. Find the total resistance between the two opposite corners. 12 equal wires, each of resistance small r, are joined to form a skeleton cube. We have to find the total resistance between the two opposite corners. We can draw a skeleton cube containing 12 equal resistances. Here we are drawing a skeleton cube containing 12 equal resistances. Each side of this cube has the resistance capital R. In this case, though in the question the resistance is given as small r, but here we can denote the resistance as capital R. Name of the cube is ABCDFGJK. 12 resistors are R1 equal R. 12 resistors of the skeleton cube are R1 equal R, then R2 equal R, R3 equal R, R4 equal R. Then in the back face of the skeleton cube we should have R5 equal R5, R6, R7, R8. Then remaining 4 resistors are R10, R9, R10, R11 and R12. In this case, between D and C, the resistance should be R3, not R6. Given according to the given condition, R1 equal R2 equal R3 equal R12 equal R. And we have to find RAJ, equivalent resistance between the two corners of this skeleton cube. That is, we have to find. To find the equivalent resistance between the two corners A and J, we can connect a battery of EMF. We can connect this battery of EMF E between that two corners A and J of this skeleton cube containing 12 equal resistances, and we can assume that the current generated from the battery as 6I. 6I is the current which will be flowing through this skeleton cube and generated from the positive terminal of the battery of EMF E. From the end A or from the corner A, total current 6I will be divided into 3 equal parts, or these 3 equal currents are 2Y, 2Y and 2I. So that means a current that will be flowing through the arm AD as 2I. So to reach from the corner A to J, we can follow this shortest path, that is, we can follow the path ABCJ, and also we can reach from the corner A to J following this path. That means we can follow the path AD, we can follow the path ADKJ to reach from the corner A to J. Similarly, the current 2Y can reach from the corner A to J following the shortest path, following the another shortest path, that will be AT, that will be ATGJ. We can follow the shortest path, that is ATGJ. That means the shortest path are ABCJ, ADKJ and AF, not T, it should be AFGJ are the shortest path, or are the symmetrical path for the total current, for the currents 2I, to flow from the corner A to J, to find the equivalent resistance, between the two opposite corners A and J of the skeleton cube containing 12 equal resistances, or containing 12 resistors having equal resistance. skeleton of cube of 12 resistors of equal resistances. A battery of EMF capital E is connected. A battery of EMF capital E is connected between the two corners A and J of the skeleton cube. Let 6I be the current generated. 6I be the current generated from the battery and which will flow through the skeleton cube. Therefore, current is equal total EMF divided by total resistance of the circuit. That means 6I divided by 6I equal E divided by Raj plus small r, where small r equal 0, which is the internal resistance of the battery, and Raj is the equivalent resistance between the two corners A and J of the skeleton cube. So finally we get E as equal 6I into Raj. 6I is the total current and Raj is the equivalent resistance between the two corners A and J of the cube, where Raj is the equivalent resistance between the two corners A and J of the cube. Now if we write what as the paths AB CJ, AD KJ and AF GJ are symmetrical with respect to the two corners, with respect to the two opposite corners A and J, these paths are symmetrical, the current 6I will be equally distributed through that paths ABCJ, ADKG and AFGJ from the corner A. From the corner A, the total current 6I will be equally distributed along the paths AB, AF and AD respectively, and from the corner B, and the current 2I will follow the path AB, CJ, and the current 2I also follow the path AD, KJ, and another current 2I will follow the path AF, GJ and this 6I current will be distributed as 2I, 2I and 2I along AB, AF and AD respectively. Now the current 2I will be equally distributed from the corner B, as I and I through the path or through the arm BC and BG. In that case, the current which will be distributed from the point B and will follow the path BCJ and BGJ, and this current 2I will be equally distributed along BC and BG. This current 2I will be equally distributed along BC and BG as I and I. So I is the current that will be flowing through the arm BC and BG. Similarly, from the point D, total current 2I will be equally distributed as I and I along the arm DC and DK. That means, and similarly from the corner F, the total current 2I will be equally distributed along FG and FK, and that current will be I and I. The current 2I will be equally distributed from the corner F as I and I along FK and FG, because and here through the arm CJ, that means through the resistance R11, entire current will be what? We know the current flowing through the resistance R3 is I, and current flowing through the resistance R2 is again I. That means at the point C, using Kirchhoff's current law, Obviously there are two currents I and I which will be flowing towards the corner C, and at from the point C total current to I will be flowing through the resistance R11, through the resistance R11, through the resistance R11 between the two corners C and J. Now a current 2I will be flowing through the resistance R7 between the two corners K and J, because here the currents coming from the arm DK and FK is I. That's why the current flowing through the seventh resistor or R7 between the two corners K and J is 2I. Is 2I. If we consider the corner G, there are two currents, that is I and I, coming from the arm FG and BJ, and these two currents I and I will flow as 2I through the resistance R6 or through the arm BJ. So there are three currents, that means 2I and 2I and 2I, which will be flowing towards the corner J, and total current emerging out from the corner J is 6I, and that current 6I will return to the negative terminal or negative pole of the battery of EMF E, of the battery of EMF E, capital E. Using Kirchhoff's voltage law, in the closed loop, A B C J E A, we get 2I into R1. We get 2I into R1 plus I into R2. I into R2 plus 2I into R12 minus E equal 0. Minus E equal 0. The battery has negligible internal resistance, that's why you have to consider only minus E. If we consider this path A, B, C, J, E, A, so there will be four elements through which we have to consider the potential difference. So or comma 2I plus R plus I plus R plus 2 in IR equal to E. Therefore 5I into R is equal to E. So we get the expression of EMF of the battery, that is E equal 5I into R, which is equation 2. Comparing equations 1 and 2, we get 6I RAJ is equal to 5I R, or comma RAJ equal 5 by 6 times of R. RAJ is equal to 5 by 6 times of R. That is the equivalent resistance between the two opposite corners A and J of skeleton cube containing 12 equal resistors of resistances R. RAJ equal 5 by 6 R, which is the equivalent resistance of the skeleton cube of 12 equal resistors. 12 resistors of equal resistances. RAJ equal 5 by 6 R, which is the equivalent resistance of the two opposite corners of the skeleton cube of the 12 resistors of equal resistances. Now we can consider additional information in connection with the equivalent resistance between the two opposite corners of a skeleton cube. Again, we can consider a skeleton cube containing 12 equal resistors having resistance R. So we can draw the skeleton cube containing 12 equal resistors. This is the skeleton cube formed by 12 equal resistors, and we can give the name, that is ABCD. Name of the cube is ABCDFGJK. That is the skeleton cube, and we have to find the equivalent resistance between the two corners A and B. RAB equal question mark. That means we have to find the equivalent resistance between the two corners of the arm AB, and we can denote the resistances of these 12 equal resistors, and we have to find the equivalent resistance between A and B. To find the equivalent resistance between the corners A and B of the arm AB, a battery of EMF E will be connected between these two corners A and B of this skeleton Q. E is the EMF, and we can consider that I plus 2I1 is the current which will be generated from the battery of EMF E. Here two paths are symmetrical, and the remaining third path will not be symmetrical. In this case, to reach from A to B, we can follow the path AB, and also we can follow the path AFGB, and also we can follow the path ADCB. So here two paths are symmetrical, that is AFGB and ADCB are the two symmetrical paths. That's why current flowing through these two symmetrical paths ADCB and AFGB will be what? I1 and I1, and remaining current I will be flowing through the arm AB. But we have to find the equivalent resistance between the corners A and B of the arm AB. Now we can show the distribution of currents here. The current flowing through the shortest path AB is I, and current flowing through the two symmetrical paths AFGB and ADCB as I1 and I1. And total current I plus 2I1 will be returning to the battery. From the corner D, current will be flowing as I2 through the arm DC, and I1 minus I2 through the arm DK. From the corner J, current will be splitted as I1 minus I2 and I1 minus I2. Total current coming towards the corner J through the arm KJ is 2 bracket open I minus I1. Now using Kirchhoff's voltage law, we get E as I plus 2I1 into RAB. Also E is equal I plus 2I1 into 7 by 12R. So that can be proved. So RAB is equal to 7 by 2R. That is the answer. That means the equivalent resistance between the two corners A and B of the arm AB of the skeleton cube is RAB, which is given by 7 by 12R, where R is the resistance of each resistor. Now we can consider another skeleton cube in which one arm is incomplete, and the cube is what? The skeleton cube is ABHK, DCGF. That is the name of the cube, and we have to find the equivalent resistance between the two ends of incomplete arm, that is RAK equal question mark, or we have to find the equivalent resistance between the corners A and K, which is this arm is incomplete. To find the equivalent resistance between the two terminals A and K, a battery of EMF E should be connected. A battery of EMF E should be connected between the two corners A and K, and the arm AK is incomplete. This is a battery of EMF E which should be connected between the two corners A and K, such that the arm AK is incomplete. In that case, we can consider a current 2I will be generated. A current 2I will be generated from the positive pole of the battery of EMF E. Now a current 2I will be generated from the positive pole of the battery of EMF E. 2I is the current which will be flowing towards the corner A, and from the corner A, current will be equally distributed. A current I will flow or will follow the path AB HK, and similarly the same current I will follow the path AD FK. Now from the corner B, I1 is the current flowing through the arm BH, I minus I1 is the current flowing through the arm BC. And also from the corner D, if we consider a current I1 flows through the arm DF, then remaining current I minus I1 will be flowing through the arm DC. So total current 2I minus I1 will be flowing through the arm CG, and from the corner G, the total current 2I minus I1 will be equally distributed along GF and GH. Current flowing through the arm GF is I minus I1, and a current I1 is coming from the arm DF, hence the current flowing through the arm FK is I, and current flowing through the arm HK is also I. So we get the total current 2I that will be flowing towards the negative terminal of the battery. Now EMF of this battery is E equal current into total resistance. That means E equal 2I into RAK. 2I is the current generated from the battery, and RAK is the equivalent resistance between the two corners A and K. That is the equation 1, which is E equal 2I into RAK. And we can prove that RAK means equivalent resistance between the two corners A and K will be what? Equivalent resistance between the two corners A and K will be equivalent resistance between the two corners A and K will be RAK equal 7 by 5 R. Equivalent resistance between the two corners A and K of skeleton cube in which one arm is incomplete is what? RAK equal 7 by 5 times of resistance R. 7 by 5 times of capital R, where R is the resistance of each resistor of the skeleton cube.